Good morning. I am Sudhir, Assistant Professor in the Department of Electronics and Communication Engineering of Engineering College, Bharatpur. Today, in this lecture, I am going to describe the basic fundamental of frequency modulation and its classification, what are the factors on which frequency modulation has been classified, and the definition of the different parameters which are generated during a study. So in this lecture, frequency deviation is one of the most important factor in the study of frequency modulation. So first we will illustrate the basic definition of the frequency modulation, and that is equal to ST is equal to A cos 2 pi FCT plus 2 pi KF integration 0 to T m tau d tau. Basically, this equation is non-linear function of modulating signal mt, which makes frequency modulation a non-linear modulation process. So, this is unlikely case of amplitude modulation in which a spectrum of FM signal is not related in simple manner to that of a message signal. Its analysis is very difficult than that of AM signal. So in first case, we propose simple two case for spectrum analysis of FM signal. One is the single tone modulation that produce narrowband signal, and the second is the single tone modulation that produce wideband FM signal. Single tone modulation is so called because of the signal which contain only one frequency is called single tone signal. So which is defined as the MT is equal to AM cos 2 pi FMT, where AM is the amplitude of the message signal and FMT is the frequency of the message signal. So instantaneous frequency of the resulting FM signal is given by FIT is equal to FC plus KF multiply MT. So if we apply the equation of MT, so finally we get FT is equal to FC plus KF AM cos 2 pi FMT. So here we are getting some extra parameter called delta F, which is called frequency deviation, and that is represented as the ratio of which is represented as the multiplication of amplitude frequency sensitivity multiply amplitude of the message signal. So delta F is equal to KF multiply AM. So finally we get the instantaneous value FIT is equal to FC plus delta F cos 2 pi FMT. So this is the instantaneous frequency of FM signal. Now we will calculate the instantaneous angle of FM signal theta it, and that is equal to 2 pi FCT plus delta F upon FM sin 2 pi FMT. The ratio of frequency deviation to modulation frequency FM is known as modulation index. Delta F is the frequency deviation of the FM signal. So modulation index of FM signal is defined as delta F upon FM. So we get the instantaneous angle of the FM signal is equal to 2 pi FCT plus beta sin 2 pi FMT. So now this value will be putted in the initial equation of FM signal, and that is equal to ST is equal to AC cos 2 pi FCT plus beta sin 2 pi FMT. So depending on the value of modulation index, we can differentiate two basic fundamental case of the frequency modulation. One is the narrow band, in which beta is very small compared to the 1 radian, and second is the wide band, in case of beta is greater than 1. So basically these are two cases in which we will study further. So first we are going to describe the fundamental concept of the narrow band frequency modulation with the help of the mathematical explanation. Before this, we obtain the FM signal equation st is equal to AC cos 2 pi fct plus beta sin 2 pi fmt. So we expand this equation with the help of formula cos A plus B, and we get AC cos 2 pi fct dot cos beta sin 2 pi fmt minus AC sin 2 pi fct dot sin beta 2 pi fmt. So after putting some assumption, and that is beta is very small compared to 1 radian, so we may approximate the value cos of something that is equal to 1 and sine of something is equal to something. So finally we get the equation of narrow band FM signal, and that is equal to AC cos 2 pi fct minus beta AC sin 2 pi fct multiplication of sin 2 pi fmt. So based on this equation, we can draw the block diagram of generation of narrow band FM signal. So this is the block diagram of generation of FM signal, and how FM signal is narrow band FM signal is generated. First we apply the signal into integrator, then product modulator, then phase shifter, and after in the last multiplication of the carrier signal, and then finally we get the narrow band FM signal. So basically if we further expand the equation of narrow band FM signal, then we obtain the narrow band equation, FM signal equation st is equal to AC cos 2 pi fct plus 1 by 2 beta AC cos 2 pi fc plus fm and minus cos 2 pi fc minus fm multiplication of the t. So if we focus the equation of conventional amplitude modulation and compare these two equations, so only the difference is that minus sign is put in the lower sideband frequency of narrow sideband FM. Thus we can say the narrow band FM signal require essential same bandwidth with the amplitude modulation. And we can say, so we know that the transmission bandwidth of AM signal is equal to twice the message bandwidth. So we can say also the basically transmission bandwidth of the FM signal means narrow band FM signal is equal to twice of the message signal. So this is the main conceptual information in case of narrow band FM signal. Basically the spectrum of the narrow band FM signal is slightly analogous to the spectrum of the amplitude modulation. So in both signal, three main primary components are there: unmodulated carrier wave, upper sideband and lower sideband. So these are the basic fundamental concept of narrow band FM signal. Students are advised to follow these instructions and going into the depth of the narrow band FM. Whenever they feel any query, they can immediate mail or WhatsApp to my number. Thank you.